Hi guys, a lesson on review of index laws, chapter 3F in your textbook. This lesson we're going to review some of the index laws that you learnt last year and apply them to solve problems. Okay, so first thing we need to have a look at is these rules here. So I'm not going to go over, well, quickly maybe. So if there is a number A in general, it will equal A to the power of 1. If there's no power above the number or the pronumeral, that means it's to the power of 1, and that applies to numbers itself. So A we call the base, and that little 1 we call the power. Okay, so 5A is equal to 5 to the power of 1 and times A to the power of 1. Okay, it's really important that we sort of remember these rules. Okay, so the index laws that you would have went on over in Year 9, A to the power of n times A to the power of n. So any number with the same base, you can, when they multiply together, you can add the powers. So for example, if I had x to the power of 3 times x to the power of 2, okay, we retain the base and we add the powers. Okay, so 3. All right, so we don't times the powers, we add them together. Okay, so that'll be x equals x5. Okay, law 2 states that when we're dividing index numbers of the same base, the powers take away. So if I had x to the power of 6 divided by x to the power of 3, okay, so we retain the base and we take away the power. So 6 minus 3 is 3. Okay, law 3 is when you have an index number to raise to another power. So for example, a to the power of n to the power of n. Okay, so for example, if we had x to the power of 5 all to the power of 2, okay, so we're not timesing it, we're raising it to the power. So brackets, we would get 5 times 2 is 10, so we'd have x to the power of 10. Okay, law 4 is the product law. So when you have two numbers in brackets multiplied together to the power, okay, so whatever that power is on the outside of the brackets, that gets distributed to each of the numbers inside. Okay, so we can say, so say if we had, all right, so let's say 3x, hopefully you know that 3x means 3 times x, so we've got something like, instead of a times b, we've got 3 times x. Now if we put a 2 here, okay, that 2 belongs, it gets distributed to the x and the 3. Okay, so you can either write it 3 to the power of 2, x to the power of 2, okay, and then you should be able to, where you can evaluate, you should. Okay, so whenever you can simplify, you should. 3 to the power of 2 is of course 9x squared. Okay. Law 5 is the quotient rule. So quotient means to resolve a division problem. Okay, so if you have a fraction, any fraction raised to a power, the power gets distributed to the top and the bottom numbers or pronumerals. Okay, so for example, if I had x over 3 all to the power of 3, okay, that 3 belongs to the x and the 3 on the bottom. Okay, so rewriting that, we could say that is x to the power of 3 over 3 to the power of 3. Okay, again, when you see something you can evaluate just means to work out, you should do it. So x to the power of 3 over 3 to the power of 3. Now, it's not 3 times 3, it's 3 to the power of 3. So 3 times 3 times 3 is 27. Okay, so that's how you evaluate or use those laws. Okay, just keep in mind that most problems from now on will sort of involve using all these laws together, so combinations of these laws. So you really have to have your head around all these. Now, it doesn't actually matter. Usually, it doesn't matter how which order you apply the rules in, as long as you do it properly, it all works out in the end. So the final one there is the zero power, which seems to be the most simple, but often is one that people get wrong. So any number or any pronumeral raised to the power of 0 is equal to 1. Okay, so for example, x to the power of 0 is 1. 40 to the power of 0 is equal to 1. Okay, I'm not going to go through why that is the case. We might be able to talk about that in class. Anyway, so I'm going to do a couple of these easy ones here. Well, they're not quite easy. They're using combinations of them, some of them. So I'm going to show you how to use them. The first index law is the product one. So looking at this, simplify the following using the first index law. So x5 times x4. Remember, we add the powers. So 5 plus 4 is equal to 9. Okay, so retain the base and keep the powers. Now, this second one here is a little trickier because it's got coefficients here. Now, these are just simple, so coefficients that you just treat them as numbers. So 3 times 4 is 12. Okay, so I usually work out the coefficients first. 3 times 4 is 12. Now, so do the A's next. A2 times A1 is going to equal to A3. Let's do the B's as well. So B times B3. Okay, so notice I'll put them in order. I usually skip this step and count how many of the pronumerals there are. There's 2 in there and there's 3 in there. So we're going to get A3. And as far as B's are, there's 1 B and 3 B's there. So there's 4 B's in total. Okay, that's your answer. All right, so let's have a look at this. This is using the second index law, this one here. Just keep in mind as well, most of the time we don't use this division symbol here. Using this is what you'll see more of going forward in maths from now on. So again, using the second law, you retain the base and you take away the powers. Okay, so retain the base, and 7 minus 5, I'll write that out, equals m2, okay, or m squared. Okay, now this second one here, again, now this is the second one's in brackets because it's actually showing you, this may be a little bit confusing, but what it's showing you is that all this first term here is divided by all this second term. Okay, so you can rewrite it like this with a vinculum, that line that separates the fraction. Okay, so we get 8x y squared. Okay, so we can rewrite that. That's what that bracket is telling us. You can get rid of the bracket now. It doesn't actually have any function at the moment. So what I can do is I can say there's 1x down there. Okay, that might help you, might not. Now, what we can do when we have fractions is we simplify the coefficients just like normal fractions. So 4 over 8 has a highest common factor of 4. So that will be 4 divided by 4 is 1, and 8 divided by 4 is 2. Okay, so the best thing to do with these is to rewrite as a fraction, 1 over 2. Okay, and then we're going to simplify our pronumeral. So x2 minus x1 is going to be, and it's on the top line. Okay, so it might not be obvious, but it goes on the top line, x1. Okay, so 2 minus 1 is 1. Now y2 minus y2, okay, if you can look at this a couple of ways. If you take away, so it's a division problem, you take away the powers, what 2 take away 2 is y0. You can write that if you want, but you might, y0 is equal to 1, okay, because of our 0 power. Okay, so let's rewrite this. Okay, 1 times x to the power of 1 times 1 is going to just be x. Okay, 1 times x is x. X times 1 is x. Okay, so, and on the bottom we've got a 2. Okay, so that's the using the second index law. Okay, I'm going to stop there and I'll make another video for the next part.